Hello, welcome back, welcome back. It's time for another PageKey stream, and today we're doing PKOS, operating system stuff yet again. And real quick, I'll just show, I just went ahead and merged in a very large merge request. And I've been trying to record a video, or actually I did record the audio for a video, I just haven't had a chance to edit it. But basically, this whole blog post is in the docs folder, blog 22 VGA regs. And this whole VJ rabbit hole thing right here is basically the video that I would have wanted to go ahead and present in an actual video, not a stream. So maybe I'll get to that eventually, but let's just, I guess we can page through this merge request, and then I think there's some more good stuff we can do with, with other stuff. So let's see. So I just merged this in, and I'll just run through it. Some new pictures for the blog article, some notes, and then lots of code changes. So John Strong's been killing it. He's been trying to just made some changes. So some changes to kernel.c and how we're plotting text. We are now including the color byte, so that's good. And then there's pretty extensive code for setting registers, but it turns out John Strong figured out that I was passing everything by value instead of by reference, so he has a separate merge request that we'll do separately. But for now, there's just a bunch of drawing code and everything, and this should be at the state where it's drawing a rectangle animation, but you get stuck, you can't get out of it. So there's a lot of improvement to be made here. So, but I know John Strong, you're working hard on this, so I have faith that we'll get something figured out for the display stuff. But yeah, today I might look into the PIIX3 driver, which is hard drive stuff, and also I'd like to get our docs cleaned up a little bit, which is pretty boring stuff, but we do have this site now, so docs.pkos.pagekey.io. There's also a doc site for Boom languages that's here too, so trying to use this format of putting everything under it in that way. But you have the blog post, and you have this nice little table of contents, all that stuff. So what I want to do is start getting, actual architecture stuff for like VGA and all that stuff, document it in a nice, easy to understand way, and that'll be that. But that's got a long ways to go. So what's next? I also wrote some issues. We got POSIX, ARM support, cross compiler. This is all stuff that John Strong and Tony Programmer suggested. Design docs also important, and then combining video notes and blogs. So I guess I can do all that offline because that's really kind of dry and not exciting. So instead I'll start a PIIX3 architecture doc here, or should I just call it, I think it should be called PIIX3. I'm going to take my template here and paste it in to index. And I guess I can delete the example too. Add that to the contents. It's an example, and we can take a look at the website. Oops. Paste this in here. And we'll think about hard drives for a second. So the way that you render these docs is I also wrote some issues against the docgen to make this simpler, but it's actually two steps right now, unfortunately. It's PageKey docgen dot, and then we're gonna start a Python HTTP server for the output directory. That should work. So oops, okay. And looks like I have an old version of PageKey docgen because it's getting messed up trying to copy an image over as if it's a text file. So let me just go. I don't know if the latest is on. It should be on pip or PyPI or whatever it is, but I'm just going to install it from here. So what branch are we on? I'll pull that, and then I should be able to do, well, 103 should be on pip. So let's, I don't know why I'm in a venv anyway. So let's just exit out of everything. And then I'll deactivate. I should be able to pip install PageKey docgen 103 in theory. Okay, that worked. And now PageKey Tech gen dot. What else? Oh yeah. Well, let's start with that and see if that works. Okay, good. Site actually built, and then we'll do that, but also that. Okay, so that built, and we have an architecture doc here. So I'm going to start filling out for PIIX3, and yeah, so we're starting it today, and it's me. No coach. I don't know what the point of that is. I'm gonna say John Strong can review this. Hopefully, maybe he'll take a look. And I don't know what Tony's GitLab username is, but I'll take a guess. Owning stage. That's nothing. That shouldn't even be in the template. I don't know what that is. Stages. None of that nonsense. Doesn't make a difference. Okay, and then thanks GitLab for this, and we'll call this blueprint PIIX3 hard driver, I guess. Okay, that's the title, and the summary we'll just say in order to store persistent data, we need a hard drive driver. The QEMU i386 system contains a PIIX3 hard drive. Is it hyphen? Hard drive? Is it one word? How do you spell hard drive anyway? Hard drive? Hard drive? Hard drive. Hard drive. Yeah, it's 2 words. Okay. Hard drive. Hard drive driver sounds weird, but so we'll start by writing some code to interface with it directly. This can later, once this driver is available, we can use it for higher level, them old things, higher level abstractions such as file systems, right? I would assume that we need to be able to control the hard drive before we can actually start using stuff like file systems, right? So that's the goal. And the other thing also, we can use what we learn from this to add support for other hard drive models. Yeah, so we'll go with that. Motivation. Oh, I just explained the motivation. I guess we'll just say we need to store persistent data or else this is really boring and useless. Don't forget useless. Okay, goals. Be able to write data to the QEMU provided hard drive. Yeah, let's get specific. Write a string be able to read the string back from the hard drive even after shutdown if same drive is attached. And I think that's basically all that I want to get done with this. I don't know, I'm open to suggestions, but that's probably going to be pretty hard to begin with. So non-goals, any file system development, out of scope. What else is not in scope that you might want to do? Any other device except for the PIIX3. And okay, that's fine. And then proposal. This part I am not sure yet because I got to go do some Googling, but let's see how that looks if we build the docs real quick. PIIX3. Don't really need that dash, do I? PIIX3 hard drive driver, summary, motivation, goals. Okay, cool. So I'll commit that, and then let's go do some research on PIIX3. Oh, I'm still in the other branch. Do I have an issue for this? Let's do this right. I really didn't write a PIIX3 issue? Okay. Add design doc for PIIX3. Let's keep it small, scoped, and yeah, create the merge request. Also, I see Tony Programmer. I see maybe John Strong watching. I don't know if there's a way to like get you guys on here too, if you're interested in that. I don't know. Maybe I can like patch in Discord somehow. I've never done that, but I can maybe figure out a way to do that eventually. But yeah, so, but otherwise just let me know in the chat if you guys want to have any inputs. And John, if you want to go through some of the stuff you've been working on, we could do that. I mean, it's really pretty open. Okay, cool. Not today, but yeah, eventually. Sweet. So let me check out my 9 branch here. 9. Okay, and I'm just gonna have a notes.md2. Take some notes, and let's just see what we can find about PIIX3. What is PIIX? Okay. PIIX is PCI IDE ISA accelerator. Intel 82371. Okay. Maybe you want to counter that. Few tags, few files and old tags that seem to be empty. Not sure. Old tags. What do you mean files were empty? Like on the file or on the hard drive? That's interesting. If there was actually files on the old hard drive, because I never did anything with it. Maybe I misunderstood. But yeah. So the PIIX, so this is IDE. So IDE is a storage thing, right? That's a hard drive. Same thing, I think. SATA, PETA, whatever. So, okay, it's IDE. Wow, it's got a lot of stuff. And it has PIIX. Okay, so we've done PIIX before with the keyboard driver, so that's familiar. What's a DMA? Direct Memory Access Controller. Okay, so it's send example in Discord. Okay. OS 15 screen C. Oh, really? It's completely empty on the tag. That's kind of crazy. And not good. Although it might not have been written yet in OS 15. Oh, I got to add a tag for OS 22 as well. I just merged, right? Let me do that. While I'm thinking about it. Okay, just so that we keep track of that. And then you said OS 15 screen.c is empty. That's kind of, I hope these tags aren't too messed up. Screen.c. Oh, you're right. What was I doing? Reorg code into sub packages? Maybe I was just moving stuff around. Yeah, that's weird. Maybe I still had it in kernel.c because I think that's where it was originally. But that's weird. Oh, I have this ASM. Maybe the it's interesting. It's a good find, actually. Okay. So let's say contains chips, controllers, same thing, I guess. To, what is this? Programmable interval timer. Okay. I didn't know what that was. And a PCI to ISA bus bridge. Not familiar with ISA either. AT. Okay, interesting. Okay, and then PIIX3 what? Just adds a USB 1.0. APIC, which is what? Advanced Programmable Network Controller? Yeah. Okay, fair. And PIIX4 and 5, who cares? I thought I found the guide for this somewhere, but I think I lost it. Is this the data sheet? Wasn't there a user guide for this somewhere? Where's the man page that tells you what's on the system? Here we go. It tells you right here. PIIX3. Oh, man. Is it just the bridge? What is this host PCI bridge? IDE interfaces. So is this PIIX3 thing just the bridge? I'm not sure. I hope not. It does say it's an accelerator. Let me reread this. I also have to look back on one of the old videos that was about PCI. It's an IDE controller. It integrates all these different things. Okay, so it's probably what we need. Okay. PIIX3. Isn't there like a technical manual for this thing out there somewhere? I think if you search by the Intel name, somewhere I have the link saved. Hold on, let me see if I can find it. I found like a really lengthy manual about this one time, but I put it in my notes somewhere and lost it. Well, I think this might be it actually. This datasheetcatalog.com thing. Maybe that's it. PIIX3. We need the PIIX3. Whoa. Some racy ads there. I'm not sure about that. Okay. What is this? Oh, it's DevWiki? Okay, good call. So let's see what we can get out of this thread. Oh yeah, that's exactly what we're looking for. Okay, enumerated PCI devices. Whoa, this is a really great description. Go to the main wiki, okay. Ooh. Oh, wow. They have it right here. Oh, nice. So that's good to have. And then maybe they actually have an article about PIIX3 too. I know they have an IDE article. Okay, I'm human. Okay, so that's all we got. But we do have the ITE. So this is good to read, I guess. Okay. What can we glean from this article? Okay. Okay, so we're looking for an IDE controller. Now I'm curious if we, where did we leave off with the PKOS actually? With the LSPCI thing. Oh, build's broken. Oh no, I forgot to do that. There we go. And then LSPCI. Okay. Wow, this looks a little funny. I gotta go fix that. Offset. Which I think you fixed too on your branch, John. That was kind of stupid of me to put that there. Okay, let's try that again. There we go. That looks better. Okay, so we get an enumeration. We see 8086 is all the Intel stuff, and it looks like device 7, it was 7 something that corresponded to our thing. But okay, so if the class code is 1 and subclass is 1, so class is 1, subclass is 1, so this, here it is, right here, 7010. Device is an IDE controller. Programming interface determines how you'll access it. Okay, so 1 prog.if is 80. So what is that? Is that decimal 80? If so, what is that in hex? 50? 50? So it's okay. Anyway. That doesn't seem right. PKOS, is that like one byte? Or one, it only has 1 byte here, right? Okay, so anyway, we have to interpret that bit. Let's see, take some notes here. So, ID controller, class code equals 1, and what else? The subclass code equals 1. PKOS, determine mode. So I guess the next step is really to figure out how to get that mode information printed out too. So maybe we can move with that. But okay, so set up the mode, and then you have to read bars, which, oh boy, so the bars tell you the IO address to use in PCI native mode. Compatibility mode. Oh, okay, so compatibility mode, you can use some preset stuff. I'm curious which mode it's in. Okay, so that just tells you if you can change the mode. And then there's the secondary channel, same thing. And then bit 7 is this master? And if it's clear, it does not support direct memory access. Okay, so you can only do DMA for the main, or the master ID controller. That's good to know. So and then native mode, read the bar to figure out IO addresses and interrupts, I guess. Okay. And then if you want to access, it's in native mode, so that sounds good. I think I might just want to see if we can get a little more info out of this. So I might add a little function to print out the information about the PCI thing, or the ID controller. So maybe I can just add in the kernels where I'm doing all these commands, which is really terrible, but I'm going to add, oh, there's an IDE test one already. Okay, that's cool. What does it do? Whoa. ID. Oh, sweet. Okay, so this is already doing it. Okay, so look at this. All right, so 0, 1, 2, 3, 4, 5, 6, 7. So, all right, this tells us everything we need to know. 7 means this is the master. These are all zeros, so it sounds like it's in compatibility mode. So we can just go ahead and use those ports. So that sounds good. Okay. F7 and 0x3F6 and IRQ14. Now what do those mean and how we use them? That's what I want to know. So luckily we're not in native mode, and I don't think we need to do anything with the master bus function, whatever that is. So that's good. We're not in native mode. We're not in native mode. Yay. So what do we do with this other stuff? I see that we're using those I/O ports from above with the bars. Okay. And command status port features error port. Okay. Which is which? Does it tell us further down which is which? That's a pretty lengthy article. Okay. So ID initialize 1 of 0, blah, blah, blah. What does this mean? Where is this coming from? Should I know what these are? Is this like a PCI thing, or where does it tell us how to use these? Detecting them, we already detected. Command status. How do I use these commands? Okay, well, I think we can actually move our design forward a little bit with what we've learned so far. So I might rename this actually to an IDE hard drive driver. And hopefully, yeah. So the proposal is, let's see, fail forward by, so I think the proposal turns into send messages, hard code the exact messages that need to be sent to the IDE controller, then generalize them into a driver that will work with more devices and in more modes. So that's good enough, and then we can say, well, what are the pieces here? Detecting IDE devices, class code, blah, detecting mode. And then we can go into, what was it? The modes, compatibility mode, native mode. And then once we detect the mode, commands maybe? Is it ATA commands? Sending commands. Not sure yet. I don't need all this blueprint stuff. Alternative solutions, once again, is to cry, because there's nothing else we could do than just grind through this, I guess. So, tempted to see what ChatGPT has to say yet again. Let's see. First, though, IDE I/O ports. Is there something on there? Yeah, where can I find these ports, their definitions? I guess we have the technical specification here, don't we? Maybe this is what they used as the source for that article. Says a PIIX3, okay. Signals. Registers. We have what? PCI, we have config, registers, there's a lot of stuff here. There's a timer counter, okay, so that's like the DMA chip is here, okay, timer counter chip, interrupt controller, okay, memory access IO map. Maybe this is what we need, PCI interface? No, we need the ISA. Is there anything specifically on IDE? ADA register block. Interrupt controller. Is there sample code in here? I don't know. So maybe I can just start reading it, see if it has any good intro material here. This is like hardware level. I don't know. I guess that's where we're at, right? Hardware level, but signal name, like this is for wiring it, right? I don't know. Seems way too low level. Signal name. Oh, here we go. This is maybe useful. Interrupt request. So, okay. So I guess this is where we would program the CPU to respond to these interrupts because it's going to send them, right? Possibly. Or is this interrupts for the drive? APIC, bus signals, system reset signals. All right, let's see if we can get into the... Whoa, that's kind of cool. Okay, so this tells you what all the pins are doing. That's a little... That's not quite what we need. Oh, cool, okay. Registers, 5 groups. PCI config. Okay. Aha! I/O assignments. That's what we need. Table 2, 3, and 4. Where's that at? Ah. Well, there's PCI config. Okay, so this is the PCI configuration. This is the config memory that we can read, which we're already doing. And I would assume that it's just... Oh. Maybe we do need to set this stuff. Vendor device. So let's... What are these fields? Vendor device, PCI command, device status, class code. Obviously read only because that's one of the things that identifies it as PCI device. So we can select our pick. We can select DMA stuff. Okay. Bus master interface base address. Is that the bar that they were talking about? IDE timing modes. Okay. It's all USB stuff. Let's not worry about that. Although I'm kind of curious. Let's not worry about it yet. Power management. Okay. Aha, command. Whoa. Bus master IDE IO registers. This is what we need, right? Bus master IDE command register, status register. This is exactly what we need to actually do some stuff. Descriptor table, status. This is secondary. So what do we have for primary and secondary? We have command status and descriptor table pointer. So I guess there's more information somewhere pointed by that, maybe. Okay. So I'm going to say page 30, table 6. What does it mean, offset from base address? Base address. The base address is programmable. The Bamiba register. Okay, that's cool. So I guess we could take a guess at what it is. Actually, I think OSDevWiki tells us that it's... Whoa. It's P... Oh, 1F0. Yeah, so maybe that's it. Hey, Matthias Conrath, how you doing? Sorry if I said your name wrong. Yeah, what's going on? Welcome. Okay, so I think we're getting somewhere with this. So from here we can gather 1F0 is definitely... Let's actually take this as well as a... let's take this as a source here too. So I'm going to say 1F0 primary ATA controller, which is IDE. Yep, so that's good. We have 1F0. I'm assuming this is the base address. Now, how big is this space? 1F0 to 1F7. It's pretty small, but it doesn't look like there's that many. So 1, 2, 3, 4, 5 through 7. Aha! Yes, I think this matches up. So this is 1F0, and then that's the primary, and then the secondary is at 1F. It's at a different place, but who cares? The base address is in a different place, but who cares? Interesting. So that's that. Ah, here we go. This matches up as well. The secondary channel is at 170, which does that match up here? 170. Yes. So there's 7 ports in a row, and those port definitions are here. 1, 2, 3, 4, 5, 6, 7. And then these, I think it's assuming that they're right next to each other, but those are all the secondary ones, so they're at a different address. But these guys, I think we can actually figure out that the master command port is 170, I think. Sorry, 1F0, and then 1F1 is reserved. 1F2 is the status. 1F3 is reserved. 1F4, 5, 6, 7. That's 4 bytes, so I guess that's a 32-bit memory address to the pointer table. Okay, so that's good stuff. How do we record that? Well, I guess I should write something a little bit more descriptive here, but let's see. The I guess I'll start with like references down here somewhere too. The IDE controller I don't know, this is too detailed. Let's just go in the notes and say command port. We can just assume that we're in when in compatibility mode 0 is the start address for the master ID controller. And I can cite the OSDev wiki on that and say that that refers to this section. Oh, can I not do the section? Detecting a PCID controller. I guess I can just link to this page. And okay. Offset 0 from the start address is the data, I'm sorry, command IO2. Okay, so we got that, and what else? Therefore, in compatibility mode, the ID master command port is 0x3F0, I'm sorry, 1F0. Is this making sense? I hope. The status port is at offset 0x2. That's going to come from source number 2 as well. Therefore, ID master command is 0x1F2 in compatibility mode. We can say command ports for compatibility mode. And then we can say what's next. Sending commands is actually next now. So that's a to-do. How do we start sending some commands? And then we can see what happens. Also, I guess we should figure out how to read that descriptor table too. So let's see. This is telling us, so command status port returns a bit mask referring to the state of channel in red. Oh, okay, so this is like an enum that tells you the status of the channel. Busy, drives ready, drive write fault, drive seek complete, data request ready, corrected data index error. When you write to it, you're executing one of these commands. Okay. Oh, this is perfect. Okay, great. Task file. So this is getting pretty deep. I wonder if we can't start messing around with some of these. Read PIO, external DMA, external. I wonder where these are all documented in more detail. I guess we could probably start reading the command status port. Did I already do that in the code somewhere? I'm not sure. Oh, yeah, we have the status. Where's that coming from? I guess I should go check out that command and probably move it out of the kernel. I don't know if it's just in here. IDE test. Okay, so it's in PCI maybe? Oh yeah, it is. Well, I guess we can keep it in PCI for now. These are all PCI ports. So let's try reading the status. So I'm gonna, can I define stuff inside of a function? That's really messy, right? I shouldn't do that. Define. Oh, I can do that. I'm gonna do that. Eventually we'll move it up and make it nice, but what did I just write in the other file? So we're gonna say ID master command is, ooh, that's wrong. That should be status. So status is 1F2 in this case, in this very specific case. So given that, let's just define this real quick and just say 1F2, right? And then if we do an, we have to do a read from that port, right? So what is it? IO port in ID master status port. Not that sloppy. Normally put them above functions. Use them. Oh, okay. Cool. Yeah, okay, so not too bad. Alright, I'll actually take your advice, because you're definitely better at C than me, so I'll put it at the top for now. Yeah, it's good feedback. So I think this is going to be a 32-bit answer that we get from the status, right? Or no, it's a U16. That's 8. No, I'm sorry, that's 4 and 4, so it's 8. Yeah, it's U8. I'm an idiot, my bad. So we're getting 8 bits from this guy, and we're going to call it status. I'll print line. ID master status. Oh, I'll print 0x. I'll just steal my hex print. And we'll do status. I guess that should work. Let's see what happens. Oh, it doesn't compile. Got a semicolon. Now what? So, okay. What if we do our ID test? Status is 0. So what does that mean? It doesn't mean anything. It means nothing. There's nothing that says 0. So maybe it's like undefined before you send any commands. But can I actually add a little sleep in here for 1,000 and then do it again? We should probably put some of this stuff into functions if we're going to get fancy here. But let's read the status once and then read it again after a delay. Oh, I can't redefine that, can I? Okay, so IDE. Yep, nice. So it prints it and then it waits and then it prints it again. It's 0 both times. So what if we okay, now send, what command do we want to send? Let's say read DMA. So I'm guessing this is parallel IO. We can read parallel IO, read parallel IO external. I don't know what that means. Read direct memory access, redirect memory access external, and we have all that stuff for writing as well. I'm just going to send a read DMA. Why not? So let's send a read DMA command just for fun. So let's do IO port out. IDE master command, which we know is define IDE master command 0x1f0 from our research. So we're going to send that, and we're going to say 0xc8. And I'm also wondering if my IO port ins and outs should have data like numbers with them. Like, should I specify 8 or 12 or 8, 16, 32-bit? But up to this point, it hasn't caused issues, or maybe it has, and I just didn't realize it. Maybe that's why we can't get VGA working. But okay, so that didn't change a thing. So that makes me think that I'm doing something wrong. But let's see what else. So reading these different ports, what's the deal? So I'm going to commit just to keep things moving. I'm going to say add research, attempt sending command to IDE. Die. IDE. Okay, Paul. So I believe most systems start in compatibility mode. You have to explicitly go to bar mode. Bar mode is desirable in the long term to avoid device conflicts. Okay, cool. That's good to know. So basically you're saying if we want to have more than one hard drive, we should get out of compatibility mode. But if we're already in compatibility mode, it should work at least to send something to whatever is default connected, right? Yeah, I think that according to our PCI walk that we do, the only connected PCI device is that one thing, I think. LSPCI, we get only one has class 1, subclass 1. So for now, hopefully we're good in compatibility mode. But my question is, why are we not getting a good status response? Or command / status port? Is there one port that is command / status and I'm just doing it wrong? Let's go back. Why did I close that guide? I think it was page 30, right? All right, maybe the code down here will help. So yeah, we got channels, okay. All right. So I see. You specify the channel. That'll change which IO address you're using. I don't know if he actually provides that function. Oh, it's right here. I'm an idiot. Okay. So channel and the register, and he's doing logic based on which register? Reg control. ATA reg control. How do we know what that is? Where do we define that? 0C. Data. What is this? This is strange. I wonder if I can find another source. How do IDE devices work? It's going to give me a really... Oh, the FDA. Good. That's exactly what I was looking for. IDE ATA controller. Thought I found a C. Actually, which OS tutorial was it when I found... There was some kind of like ATA driver that I found somewhere. and it's in the notes for one of the old videos. Let me look for it. Oh no, is my site down? Oh, there we go. Projects, come on. PageKey operating system. I gotta move these over. Which one was it? I think it was this PCI video in which we talked about ATA driver. No? You know what it was? It was that other one. This is like more PCI, I think. Oh, here it is, more PCI. That's the one. ATA is the one that I got way too into. So let's see. There's definitely a source in here that's an ATA driver. RTEM's ATA driver guide. Here we go. OS Dev ATA driver. Whoa, that might be really helpful. SATA drive, SATA drive. Okay, sure. Now these two drivers might make more sense now that we did a little initial research. So what's it even saying? Generic interface to an ATA device, which I think is the same as what we're trying to do. IDE driver. So I'm going to actually re-add these to my notes here. And we can also say ATA driver, OS Dev. That's going to be right here. And this looks pretty nice. Oh, look at this. Okay. ATA primary I/O is the same as what we're trying to use. So let's see how they're using this. Select drive. Wow. Oh, this is awesome. What functions do we have? Select drive, primary IRQ, secondary IRQ, identify, delay, poll, read. Oh, this is great. Okay. Init. So what do we have to do to init? Sorry, I yawned. Primary IRQ. Set interrupt. So do we need to do interrupts to get things done here? Maybe. Wow, this is pretty intense, pretty involved. ID select drive. Okay. I don't know. Not sure what to make of this quite yet, but let's see. What else? So ATA probe. I don't think that we really need to do these identify steps yet. So it calls the probe after it maybe sets up the interrupts, it looks like. But then first check the primary bus, master drive. Okay. ID identify, primary master. And then it does some stuff. And then whatever. Okay. ATA read 1. Oh, this is neat. So it like selects the ports. Commands, and does out. So that's where the rubber meets the road with a bunch of constants that I don't understand. Register, selections, okay. Okay, this is cool. IO, what is that IO variable? Oh, it's just set to 0. And then it gets set to whatever drive you want to be using. Okay, so that's fair enough. And it sits there and polls for the address. Okay. So this is what, reading? Is there a writing part too? Maybe not. But let's go back to this primary address. Where is it being used? So it's selecting the drive. I don't think we need to do that yet either. I think it's just default selected. Okay, so I/O gets set to primary I/O. and it's trying to identify. ADASpec says these values must be set to 0 before sending identify. Now send identify. Okay. Read the status port. Oh, we should do that too. Pull until BSY is clear. I don't know what that is. But, I mean, I guess we could at least try sending that identify command, but are we doing an import? If status, I guess, is not 0. Oh, BSY must be busy. So SR busy. So we're going to sit there and pull whether it's busy. Pull until busy is clear. Okay. And then status equals reading the status again, which we did up here. Do it again here. If the status is, I suppose, non-zero, and what? Okay. Oh, I see. If status binary ended with, I missed that. I thought that was a logical AND. So if status binary ended with the error, so in other words, if the error bit is set, then okay. My bad, I'm not used to working on this level. Okay, so we read the status. If the status is not 0, otherwise it just zips on out of there. But if it's not 0, then we read the status port and logical end it with busy. So we're checking the busy byte, or bit rather. Then, we're just going to sit there and wait until it's not busy. And then we read the status thing again. Okay. I think I get it. And then if it is an error, then just return. If it's, what is DRQ? And we would go to, this is really hard to understand. Okay. Module print becomes cool. All right. Now actually read the data. Set task 0. And then it's going to put this into memory, I guess. Import W. So a word in from the IO port. So are these all IO ins and outs, and it's just going to read one word at a time? That seems crazy. Then the buffer just puts it into the buffer. Reg data. Set task 1. What is this set task thing? Oh, you know what? This must be protecting against multi-threading or whatever, so that people know it's like a lock, right? I would assume. Okay, so that's cool. So ID identify, read the data, 256 words. So maybe that's the table that it talked about. I think it talked about a table. Yes, the descriptor table. And it puts it in the IDE buff. I guess it's 512 really, but so okay. Alright, so you got the drive. So how do we actually read stuff though? IO and drive. Those get set. You set the command. Hard drive, device select. What is this? Like, where's the comments on this thing? Alright, let's read this. Also, yeah, I don't know how much more of this I can look at until my eyes burn out, so let's try to get through this R Times article, but I guess I can take a few notes on what we just mentally stepped through here first, and just say that ID identify function. Well, the other thing of note was note ATA primary IO matches adder for master ID controller in compat mode, and ID identify. So we stepped through that and we said that it's basically it does a bunch of stuff that we don't care about, but also sets a bunch of registers, sends an identify command, reads status, waits until busy bit is not set, reads if status is 0, done, read status again, and then checks error bit, waits for something, reads 256 words to memory at ID buff address, whatever. Could this be the, what was it called? Okay, so we got that, and what else? What else? I guess I was going to go look at that rtems source. Oops, I put this in the wrong section. This goes down here. That was the OSDev one. Okay. rtems. What's the deal with this thing? ATA driver provides generic interface to ATA device. ATA driver is hardware independent implementation of mandatory. PIO mode. Is that pulled input output maybe? Pull interrupt. Alright, whatever. So that's interesting. PIO mode, you can do polling or interrupt driven. And I guess DMA mode is a whole different animal. Ooh. There's a reference implementation. Where is that? I gotta find that somehow. But let's keep reading. ATA initialize routine is blah 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 blah. All right, I don't know. Another issue that I'm going to write here is to add scrolling for that terminal. PIO is slow, but easier to implement. DMA is the way to go for performance. Ooh, okay. Cool. Well, I'm all about easy to implement to start with, and then we can figure out DMA later. But that's good info. Thanks. So, okay. So PIO... I'm just going to note that down. I'm gonna call it Paul. PIO slow. DMA performance. but easy. Good, good, good. Okay, so what else? I guess I'm getting to the end here of what I'm able to think about even. I would like to find that reference implementation that they're talking about. But I guess I'd have to figure out what board thing this is written for and all that stuff. And where they're Git repositories, git.rtems.org. Oh no. Better off on Google. Here we go. Whoa. So it's just the same thing again, but it doesn't link to it. ATA driver. Where is this? Oh, CPU kit. Okay, rtems. CPU kit. Libblock. Source ata.c. And of course that's not there. Is there a better source for this? Oh, here we go, rtems. And then we're looking for CPU kit, lib, block, source, and there's still no ATA.c. Is there an IDE? Oh, there's an IDE part table. Oh man, this stuff. Alright. So, yeah, open to suggestions, but I think I might just have to stop here. And I definitely learned a lot about IDE from this, so I'm feeling better. And, you know, we tried sending some commands, but they didn't really work. So we might have to refer back to that reference implementation with its ports and things. But, yeah, maybe we'll do more hands-on coding next time for this. But yeah, I think that's it. Or honestly, we could switch back to doing VESA and VJ stuff if you're interested in that, John. But yeah, I'm just going to commit this and say add more notes and leave that out there. And that might be it. Just trying to think of what else. Yeah, I guess when I'm not streaming, I can fix up the docs so that they're a little bit more cohesive. And we'll keep working towards an ID driver. I think next time we're just going to have to start writing some code and seeing what happens. I mean, we did that, but we didn't probably do it right. So maybe we can try doing that identify command from the reference implementation next time. I guess I'll leave myself a note. Next action, I guess. Add identify command using osdev driver as reference. And yep, I think I'll call it there. So thanks for watching, and yeah, I appreciate you guys. I'll see you for the next one for some more PKOS. So have a nice night. See you later.